Next, let us proceed to the question that a regular hexagon is drawn with two of its vertices forming a shorter diagonal at z equal to 2 and z equal to 1 minus I root 3. And the other four vertices are. So here you need to find out the other four vertices of a regular hexagon. First of all, let us describe the regular hexagon in this way. See, this is the regular hexagon which has been described. This is regular hexagon where you are given with the two of vertices whose join of the points is the shorter diagonal. Well, this is, let us take it as A, B, C, D, E and F. In fact, we'll take it as say Z1, say Z2, say Z3 and Z4 and Z5 and Z6 represent the points A, B, C, D, E on the regular hexagon. Now, how come you take that Z is equal to minus 2, Z equal to 1 minus I root 3? From origin plane, let us take this as Z, that is equals to minus 2, and Z equal to 1 minus I root 3, that is shortest diagonal means, see here, these are the diagonals which are the longer diagonal. This is one diagonal and this is one diagonal and this is one diagonal. Shorter diagonal is the diagonal joining these 2 points. AC is the shorter diagonal. When AC is shorter diagonal, then this must be Z is equals to 1 comma minus root 3. So when you are plotting this point here Z is equal to minus 2 comma 0. Obvious that this must be the coordinate axis, that is x dash. And obviously this must be the coordinate axis y. This is yi and yi dash. And this must be the origin. So here, when we join this origin to these things, obviously this is the magnitude, that is the radius of the hexagon. This one, this is the radius of the hexagon. So when this length is equals to 2 here, because z indicates the distance from the origin, that is this one is 2, that is magnitude is 2, so everything is equals to 2 and this is also equals to 2. This is coordinate axis. Now this is 1 comma minus root 3. So in this hexagon, each angle, this is equals to 60 degrees. Each is equal to 60 degrees. As it is a regular hexagon, each is equal to 60 degrees. When each is equal to 60 degrees here, we'll proceed in this way to find out. Let us take A, B, C, D, E, F, or Z1, Z2, Z3, Z4, Z5, Z6 be the regular hexagon where A is equals to minus 2 comma 0 and so C is equals to 1 comma minus root 3. So AC, the shortest diagonal, is equals to minus 2 minus 1 root 3 square is plus 9 plus 0 plus root 3 square is equal to 3. That is equals to 12, that is 2 root 3 is the length of the shortest diagonal. So therefore from geometry we have the length of shortest diagonal is say 2r into sine of 60 degrees, that is equatorial angle, which is equals to 2 root 3 implies the radius of the hexagon is got by 2 units, which is the radius of hexagon. When it is a radius of hexagon, then we can find out in Z1, Z2, Z3, Z4, Z5, Z6 regular hexagon. As let us take Z1 is equals to say Z, that is equal to minus 2. Then obviously Z4 will be is equal to minus of Z1, that is equal to plus 2. So therefore one vertex is got, Z4 is equal to plus 2 comma 0, that is say number 1, vertex number 1. This is a vertex we got, Z4 is got, this is plus 2 comma 0. Now to get other vertices, let us find Z2. To find Z2, let us use the modular form of the complex number, that is r into cos of theta and r into sine of theta, which is equals to 2 into cos of 120 degrees and 2 into sine of 120 degrees. Implies this is equal to 2 into cos 120 is minus 1 by 2 and 2 into sine 120 is root 3 by 2. Hence this is equals to minus 1 comma root 3. So therefore we have got another vertex Z2 is equal to minus 1 comma root 3. This is say number 2. Next, to get Z5, observe from the diagram, that is r cos theta or sin theta, that is 2, but vectorial angle is 60, and this is 2, vectorial angle is 60, that is sin 60. Implies 2 into 1 by 2 comma 2 into root 3 by 2, which is equals to 1 comma root 3. Therefore Z5 is got by 1 comma root 3, that is say number 3. Now the last vertex is z6. To get z6 from the same formula, z is equal to r cos theta or sin theta. From that we have this one as 2 into cos of minus 120 and 2 into sine of minus 120, which is equal to 2 into cos of minus theta plus cos theta. Cos 120 is minus 1 by 2, but sine of minus theta minus, so therefore minus of sine 120 is plus root 3 by 2. So therefore it becomes minus 1 comma minus root 3. Hence z6 is got by minus 1 comma minus root 3. Say number 4. So therefore finally what we can say, therefore the rest of the vertices are 2 and number minus 1 comma root 3 and 1 comma root 3 and minus 1 comma minus root 3. In fact you can write it as 2 comma 1 comma root 3 and minus 1 plus or minus root 3. So these are the vertices which are left rest. So which option is going to be the correct option here? That is none, because here root 3 is there, root 3 plus or minus I minus 1. So option D is going to be the correct option for this question.